Schrodinger's cat, alive and dead at the same time. It's the most famous animal in physics. But here's the twist. Schrödinger invented it to prove that idea was ridiculous. He wasn't celebrating quantum weirdness. He was protesting it. This is the story of physics' strangest thought experiment, confident, and what it was actually arguing. It starts in 1935. Quantum mechanics is barely a decade old, and it works beautifully. For atoms, an electron can be in a superposition, a combination of states with no definite answer. Albert Einstein hated where this was heading. That May, he and two colleagues published the famous EPR paper, arguing quantum theory was incomplete. Then, he started writing letters to Erwin Schrödinger. In August, Einstein offered a vivid image, a pile of gunpowder that may or may not have exploded. Quantum mechanics, he wrote, would describe it as a blend of not yet and already exploded. Schrödinger raised him one better. In November 1935, in the journal Naturwissenschaften, he described what he himself called a quite ridiculous case. You know it as Schrödinger's cat. Here's the setup. A cat is sealed in a steel chamber. Inside, a tiny radioactive sample, so tiny that in 1 hour, maybe one atom decays. Maybe none. 50-50. If an atom decays, a Geiger counter clicks, a hammer falls, and a flask of poison shatters. The atom's fate decides the cat's fate. The atom is a quantum object. It sits in a superposition of decayed and not decayed. But the equations don't stop there. They drag the whole box in with it. Taken literally, the wave function of the entire system has the living and the dead cat, in Schrödinger's words, mixed or smeared out in equal parts. And that was exactly his point. Nobody has ever seen a smeared out cat. If the theory seems to predict one, something in our understanding is missing. The cat wasn't a mascot. It was a protest sign. So why don't we ever see it? The modern answer has a name: decoherence. A cat is never isolated. Air molecules, photons, the counter itself, the environment constantly interacts with it, and every interaction leaks information out of the box. That interaction destroys the delicate interference between alive and dead almost instantly, far faster than any human could look. No conscious observer required. For anything cat-sized, the quantum blur is gone before it starts. Does that settle everything? Not quite. Why we get one definite outcome, the measurement problem, is still debated. Decoherence explains why we never see the superposition. Interpretations argue about the rest. But here's the beautiful twist. In the lab, small cat states are real. Serge Haroche put microwave photons into superpositions of two opposite phases at once. David Wineland did the same with trapped ions. In 2012, the two shared the Nobel Prize in physics for measuring and controlling individual quantum systems. 90 years on, Schrödinger's protest sign has become a research program. Physicists keep building bigger cats, probing exactly where the quantum world hands over to ours. The cat was never about the cat. It was one question, sealed in a box. Where does quantum end and reality begin? Subscribe for more Quantum Actually Explained.